so we're back with homework number 3, and this is problem 2, ES110, spring of 2021. And we have these chains. They're going to be used to pull down a UHart building. I don't know why we're doing that. And a configuration shown where theta A is 30 degrees and theta B is 35 degrees. The chain has a breaking strength of 3.5 kilonewtons. And we want to determine the maximum load, FA, that can be applied at A. You must draw a free body diagram. So let's go to it. And so I have already written my name and some of the deets on there. So let's draw this thing out here. This is problem 2, and it looks something along these lines right here. I don't know if I'm going to bother trying to make it look like chains. That might be just a little extra, huh? Some of what the kids used to say, call things extra. Alright, so there's some. Oh, that looked ugly. That was awful. I feel so bad about that. I'm going to erase it. It's not really even all that much better. But look at that. Look at me go. Alright, so this doesn't know if that's going to be work out right, So chain of fools. See, it looks like chains, right? So I didn't do it well over there, so we'll fudge it. Okay. Kind of. There you go. I bet you guys could do better chains than me. You get bonus points for the best drawing. What do you think? Sound fair? So I have a little ring right here. And alright, so the force is not in line with that one, so I'm going to try to make sure that I kind of indicate that. Alright, so this one is horizontal right here, and I do have an angle right in there where we're going to say that that's theta B, and we have an angle right in here where that's theta A. This is FA, because this is long at A, this is C, and this is B, and we're given. I'm being distracted. I can hear somebody in the background. It's like really kind of loud to me. I'm not sure if you can hear them. Theta A is equal to 30 degrees. Theta B is 35 degrees. And we want to find, I can't remember, have I been underlining these? This feels kind of good to underline them. I'm going to find FA. Let's see, I want to say it in the given max chain is 3.5 kilonewtons. Find FA max. Okay, so there's just a slight difference here in doing this. We don't know which of these chains is going to be 3.5, but one of them needs to be 3.5 and one of them needs to be less than that, right? So that's like the big idea here. So this is sort of almost a design problem, because in many design things we have some type of criteria that the thing is supposed to meet, and we're going to set what like maybe the load limit of the thing is going to be. Just a slight difference. We're going to keep X and Y here aligned. We'll have this going to be the ring, maybe. We'll even draw it like a ring, maybe. We'll draw the force that's acting here. One of the forces is going to be in this direction. That's going to be from that chain. And I'm going to have another chain that's going to be coming up this direction right there. So this is FA. We can call this FAB. And we call this FAC. We can call it FC and FB if we want to. I don't know if it makes any difference to us. This angle right here, I'm going to say that this is going to be 90 degrees minus theta b. It's just going to be easier for me. I don't know necessarily that it's matters all that much, but I kind of liked it better that way. This angle right here is going to be that theta a, right? So there's theta a, and theta c is completely in that direction. So I think we have everything there. We might not want to make that look like it's part of the drawing, right? So some of the forces in the x direction. One of the things we want to try to decide is which one of these is going to be the maximum. Is really what we're going to try to find out. We could try it both ways and see how that works out right here. So we go the sum of the forces in the x direction. Since I haven't solved this problem, so I don't necessarily know what the solution is going to be just yet. But I think let's go ahead and just set the thing up here where we're going to say that FA, it's going to be negative FA cosine of theta A. It's going to be plus FAB times the cosine of 90 minus theta b. I didn't leave myself enough room. I'm going to go down here. Plus FAC is equal to 0. Right there, right? So we know that's going to be true, and probably going to help us out here a lot to what I would think to do is to replace FA. Yeah, I think that's going to be the best strategy. Then we can see which is larger, AB or FAC, right there, right? So, so that's my strategy. Take the sum of the forces in the y direction, come up in there, and so I'm going to have a negative FA sine of theta A, and then I'm going to have a positive FAB times the sine of 90 minus theta b equals 0. So I could say that FA is going to be equal to sine of 90 minus theta b divided by the sine of theta A times FAB. And I can put him back into this equation right here. So this is like maybe equation 1, this is equation 2. So combine 1 and 2 right in there. So I put him back into place, and so I have, and maybe I want to start putting in numbers now. I don't know. Sine of 90 minus theta b divided by sine of theta A, FAB, right? So we put him into place right up in here, and that's negative, by the way, cosine of theta A, and I guess I decided not to. I'll put the thing back in. Plus FAB cosine of 90 minus theta b plus FAC equals 0. Okay. Let's shove some numbers in here, right? So I'm going to go ahead and put this in here in brackets and say the cosine of 90 minus theta b is 35, and that's going to be minus the sine of 90 minus 35 divided by the sine of theta A, which is 30, times the cosine of 30. And that's going to be FAB and plus FAC equals 0. So what are we going to find right here? Hopefully this is a negative number, because we're going to have some problems if it's not a negative number. 90 minus 35. All right, so 55. Everywhere we see there, we're going to do 55. So we have cosine of 55, and we're going to take the sine of 55 and divide it by the sine of 30, right there, right? And then multiply it by the cosine of 30. Boom. And we're going to subtract that out. Yep, we get a negative number. Whew. And so what we find here, we'll bring this over here, is FAC is equal to 0.8452 FAB. Right? That means that, therefore, that means that FAB is larger than FAC. And it kind of stands to reason that it would be, right? Because this thing has to sustain all of the... Does that make sense? Nope. This is going to be larger, right? FAC is larger than FAB. Okay. Yeah, I'll buy that. Because this is taking up a lot of the horizontal of this thing. This doesn't have to take nearly up as much horizontal as this one does. Okay, so what we want to say, therefore, FAB, excuse me. Did I just say this wrong? I just said this wrong. Yeah. This is the larger one. FAB is larger because this one says this one is 84.5% of that one. So FAB is greater than FAC. Therefore, an FAB is equal to 3.5 kilonewtons. Sorry, I had that out of the range. So, so we want to find FA. Okay, so that's all we asked for was FA. So we can just go ahead and put FAB in at 3.5 right in there. So we could find that FA is equal to sine of 55 degrees divided by the sine, let's put it in this here, this is 55 degrees, of theta A, which is 30, multiplied by 3.5 kilonewtons, and what we're left with is 55 sine 30 sine divided 3.5 times right there, right? So it can handle 5.734 kilonewtons. So the answer is FA max 5.73 kilonewtons, and I just decided it felt like making it 3 sig figs. Ta-da! And we're done. I was tired late at night. I've been messing around. I had band practice last night, so I didn't get a lot of this stuff done that I meant to. We are done. Let's see what the how much time is this taking us? 13 minutes. Okay, it's fair.